I want you to imagine, just for a second, that you are building a massive, towering skyscraper.
Okay, that sounds like a big project.
Right. But instead of handing over a set of highly detailed, precisely measured blueprints to your construction crew, you just gather 100 brilliant bricklayers together
Uh-huh.
and you just give them a general vibe of what you want the building to look like. And then you just cross your fingers and hope they figure it out together as they go.
I mean, that sounds like a fast track to a very expensive, very dangerous pile of rubble.
Exactly.
You'd have, like, staircases leading to nowhere,
Yeah.
and entire floors collapsing because, nobody actually agreed on where the load-bearing walls should go.
Which is completely absurd to think about in the physical world. I mean, nobody builds like that.
No, of course not.
But that is actually exactly how the tech industry has been trying to build advanced multi-agent AI systems over the last few years.
Yeah, that's spot on.
We've been treating these AI models like a group of exceptionally talented jazz musicians. We put them in a room, give them a loose theme, and we just hope they improvise a beautiful symphony.
That they don't.
No, they really don't. And based on a fascinating set of leaked notes and analysis regarding Claude Code that we are doing a deep dive into today, that jazz approach is completely collapsing in production.
It really is. We are witnessing a fundamental architectural failure across the entire industry right now.
So what's actually happening when they try to run these systems?
Well, when you let these multi-agent systems just freestyle, they inevitably break down. And it is actively crashing data pipelines for companies everywhere.
Wow. So it's not just a theoretical problem?
No, not at all. The source material we're looking at today points to a massive paradigm shift. The industry is finally realizing that throwing more computing power and, more money at AI agents is just a dead end.
Which is usually Silicon Valley's favorite solution, right?
Oh, absolutely. But instead, they're secretly moving towards something called architectural determinism.
Architectural determinism. I mean, the pre-scripted future of agency. I really want to pull that apart for you today.
Yeah, it's a huge concept.
Because it suggests that what we actually need, desperately, isn't a better jazz band. We need an orchestra rigidly following sheet music.
Right. And to understand why this shift to a highly structured, deterministic architecture is happening, we first have to look at why the improvisational pipelines are collapsing in the first place.
Okay, let's start there. Why are they failing so badly?
It really comes down to incredibly unforgiving math, specifically the math of compounding errors.
I'm trying to wrap my head around this because when I look at the benchmarks for these AI agents, you often see success rates of like 95%.
Sure, which sounds great.
Yeah. On its own, in a vacuum, 95% sounds fantastic. That's a solid A in school.
Yeah.
I mean, if I'm a business owner, I would happily hire a human employee who performs complex tasks with 95% accuracy.
Most people would.
So where does the math actually break down?
It breaks down the exact moment you ask that agent to work in a team.
Ah.
Because in a multi-agent system, tasks aren't completed in a vacuum. They are passed down a chain. So Agent 1 completes a task, hands the output to Agent 2, who processes it and hands it to Agent 3, and so on.
Right, they're collaborating.
But if every single agent in that chain has a 95% accuracy rate, you don't get a final output that is 95% accurate. You actually have to multiply those probabilities together.
Because the second agent is building its work on top of the first agent's work.
Exactly.
So if the first one makes a tiny mistake, the second one just assumes that mistake is a fact.
Precisely that. So let's just do the math real quick. If you chain just 10 of these steps together, each with a 95% success rate, those errors compound. Your overall accuracy at the end of 10 steps drops to about 60%.
Oh, wow. So you are barely beating a coin flip after just 10 handoffs.
Yeah, and enterprise environments don't usually have 10-step pipelines. They require dozens, sometimes hundreds of steps to process complex data or execute software development.
I can see where this is going.
Right. If you take that same 95% accurate agent and chain it across 100 steps, your final accuracy plummets to 0.6%.
Wait, really?
Yeah, it is effectively zero.
So the pipeline doesn't just degrade a little bit, it completely disintegrates.
It shatters. And the source notes actually highlight a specific real-world example of this happening in production.
Yeah, I saw that. Let's talk about that leak.
So the leak details a team that had implemented a multi-agent system. And at one point in the chain, Agent 3 simply hallucinated.
This totally made something up.
Exactly. It made a mistake, generated a completely false piece of data, and then confidently fed that wrong information to Agent 4.
And Agent 4 didn't catch it.
No, Agent 4 just assumed Agent 3 did its job perfectly.
Yeah.
So it built an entire logical framework around that hallucination and then passed it to Agent 5.
Oh, man.
By the time the whole process finished, the final output was completely unusable fiction.
So what is the tech industry's default response to this? Because obviously companies know their pipelines are breaking.
Yeah, they do.
I have to assume the immediate reaction is just the classic tech move, right? Just throw more money at it.
That has absolutely been the Band-Aid. The prevailing theory was, well, if the 95% model is failing, let's just buy the premium, highly expensive frontier model for every single part of the pipeline.
The heavy hitter.
Right. The source details how this exact team tried to solve their Agent 3 problem. They decided to fork out a massive amount of money to use a top-tier model. The notes refer to it as Opus 4.6.
Okay.
And they use it for every single inference step.
Okay, let's define inference step for you real quick, just so we're clear on what they were actually paying for here.
Sure. An inference step is simply a single moment where the AI model generates a response or makes a decision based on the prompt it was given.
So every time the AI thinks and outputs text or code.
Exactly. That is an inference step, and you pay the provider for the computing power it takes to generate that specific output.
Got it. So they took this insanely expensive Opus 4.6 model and used it for every single tiny step in the chain, hoping the sheer computing power would fix the hallucinations.
They did.
Did it work?
Well, the accuracy of each individual step did bump up slightly.
Yeah.
It went from 85% to 95% per step.
Okay, so small improvement.
But their computing bill skyrocketed by 30 times.
30 times the cost. That is an astonishing premium to pay.
Huge.
And I'm guessing, based on the math we just did earlier, that it didn't actually save the pipeline.
No, it collapsed almost immediately.
Wow.
Because, like we said, 95% accuracy compounded over a few dozen steps is still just a coin flip. They essentially paid a 30x premium to still flip a coin.
That is wild, but this brings up a really glaring issue for me.
What's it about?
We are talking about massive multi-billion-dollar models trained on essentially the sum total of human knowledge. Why can't they just logically reason their way out of a mistake?
That is the million-dollar question.
I mean, if I hand a flawed report to a smart human employee, they can look at it, realize something doesn't make logical sense, and just correct it. Why doesn't the AI do that?
This is where we have to confront a really hard truth about the illusion of thinking in AI.
Okay.
Large language models do not possess real internal reasoning.
Mm-hmm.
That is simply not how they are built at a mechanical level. They are auto-regressive.
Meaning they are essentially just predicting the next most likely word in a sequence over and over again based on statistical patterns in their training data.
Exactly.
It's basically autocomplete on steroids, not an actual internal mental model of the world.
Right. And the source notes are very blunt about this. They point out that even foundational AI pioneers, like Jan LeCun, agree with this assessment.
So it's not really a controversial take among the experts.
Not at all. There is no internal logical sandbox where the AI tests its ideas before speaking. And what's really fascinating is how this exposes the whole flaw in that throw money at it strategy.
How so?
Well, the advanced high-effort models, the ones that take longer and cost way more, actually score identically to low-effort runs on hard logic benchmarks.
Wait, really? A 30x increase in cost for identical logic scores?
Yep.
What are you actually paying for then?
Verbosity.
You mean just talking more?
Exactly. You are paying for a higher word count. They burn more tokens and generate longer, more elaborate explanations to arrive at the exact same auto-regressive result.
Wow.
So you aren't paying for better logic. You're just paying for a more verbose process.
I have to push back on this terminology we use every day, just on behalf of everyone listening right now.
Go for it.
Because we hear the word agent thrown around constantly. It implies autonomy, intelligence, and reasoning.
It does.
But if they aren't reasoning, and it's just auto-regressive word prediction, calling them agents feels incredibly misleading.
I agree completely.
It's like paying a massive premium for a lawyer who just talks louder and longer in the courtroom, rather than hiring a lawyer who actually knows the law. You're basically paying for the confident performance of competence.
That is honestly the perfect way to look at it.
Mm.
You are buying performance, not mechanical execution.
Right.
And that realization that more thinking and more money completely failed to fix the compounding errors is exactly what triggered the shift toward architectural determinism.
Because you realize you can't fix it with more tokens.
Exactly. If you can't make the AI think better, You have to stop letting it try. You have to force it to act like a machine.
Which brings us to the team at Openservai. Tell us about the people who looked at this compounding error math and decided to build a completely different architecture.
Yeah, so the Openserve team didn't just stumble into this. Their CTO has actually been building machine learning systems for over 20 years.
So they have some serious pedigree.
Oh, absolutely.
Yeah.
The core team comes out of heavy hitting environments like NVIDIA, Amazon AI, JP Morgan, and Tron.
These aren't just guys tinkering in a garage.
No, these are people who deeply understand what happens when a high-stakes enterprise pipeline fails. They knew the freestyle era had to end.
So they built an environment entirely reliant on architectural determinism. What does that actually look like in practice? Like, how do you mathematically stop an AI from freestyling?
You basically lock down the environment with structured decision nodes, explicit transitions, and terminal states.
Okay, that sounds very technical.
It just means that in their platform, an agent cannot drift off topic. It cannot invent states or tasks out of thin air.
Give me an example of a structured decision node, because normally you just type a prompt into a chatbot and see where it goes, right?
Right, but in a deterministic system, you don't do that. Instead of giving the AI a broad prompt like, research this competitor and give me a summary, the architecture dictates a rigid node.
What does the node say?
It says something like, execute search query A, extract revenue number, stop.
And that's it.
That's it. The AI has absolutely no permission to do anything other than pull that specific number. Once it does, that node hits a terminal state, meaning the task definitively ends.
Wow.
There is no endless loop of agents chatting with each other and drifting away from the core goal.
It's just a closed, rigorously defined loop. I really want to unpack the division of labor they've created here, which they call the blueprint methodology.
That's a great concept.
It's kind of like the difference between asking a group of artists to paint a house together and just hoping their styles blend.
Which would be a math.
Exactly. Versus having a master architect draw a precise, unyielding schematic and then hiring incredibly efficient, affordable painters whose only job is to just stay inside the lines.
The architect and the painters. That is exactly how Openserve operates.
So how do they split that up with the AI models?
Well, instead of using an expensive frontier model like Opus 4.6 for every single step, which is what blew up the budget of that earlier team we talked about, Openserve uses the expensive advanced models for one thing only.
To draw the blueprint.
Exactly. To draw the ironclad blueprint, you use its massive context window to define the structure, set up the nodes, and map out the exact steps required to solve the problem.
Okay, that makes sense.
But once that blueprint is drawn, the frontier model's job is completely done. That schematic is then handed off to much cheaper nano-tier models.
And these smaller models don't need to reason because they aren't being asked to invent the steps at all.
Right.
They just execute the blueprint. They are literally just reading the sheet music.
And they do it with near 100% accuracy at massive scale because the parameters are so tightly restricted.
And I imagine the cost savings there have to be huge.
The return on investment is staggering, honestly. The source notes that this structured graph approach is between 74 and 122 times cheaper than using frontier models for everything.
Wait, 122 times cheaper?
Yeah.
That completely changes the unit economics of AI for a business. I mean, it's not even in the same ballpark.
It really does. We are talking about nano-tier models operating on a structured graph that are actively beating massive GPT-class models that are just out there winging it.
Which is incredible.
And Openserve actually has a reasoning paper detailing this exact methodology that is currently in peer review at a top 1% AI journal.
Which brings us to a massive pivot point in our deep dive today. Because once you solve the hallucination problem, once you lock down the architecture so the agents physically cannot drift away from the blueprint, you don't just get a cheaper, more reliable pipeline.
No, you get something much bigger.
You unlock an entirely new paradigm. You unlock the machine economy.
This is where the implications get truly massive. And we need to emphasize that this isn't theoretical whiteboard stuff.
Right.
The source makes it extremely clear. The UAE government is already running this live in production through a tech partnership with Neil.
The UAE government, I mean, that's not a tech startup running a fun little beta test. That is a sovereign nation putting its actual infrastructure on this system.
Exactly. This is way beyond the pilot phase. These agent systems are backed by over 10 enterprises and multiple governments.
Wow.
They are trusting this lockdown deterministic architecture to run actual high-stakes pipelines. And to understand why they trust it, we have to look at the anatomy of the execution layer that Openserv built.
Let's break that anatomy down for the listener, starting with what they call shadow agents. What are those?
Think of shadow agents as a quality assurance department that literally never sleeps.
Okay.
In the Openserv stack, a shadow agent operates entirely in the background. Its sole purpose is to audit every single output generated by the worker agents against the original blueprint.
So before the output even moves to the next step, the shadow agent intercepts it.
Yes, exactly. It compares the worker's output to the rigid constraints of the blueprint. If a worker agent steps 1 millimeter outside the lines, the shadow agent catches it.
And then what?
It flags the error, and it forces a correction before a human being ever even sees it.
Okay, that makes perfect sense. You basically have an automated inspector on the assembly line.
Right.
But the next feature is what really caught my eye in the notes. The shared file system. I want to spend a minute here because earlier we talked about how multi-agent pipelines collapse because errors compound when agents pass data to each other.
The whole 95% compounding problem.
Right. So how does a shared file system actually fix the AI equivalent of the telephone game?
The telephone game is actually the perfect analogy for this. In a traditional multi-agent setup, Agent A reads a massive document, summarizes it, and passes that summary to Agent B.
Okay.
Agent B acts on the summary, makes some changes, and passes its own interpretation to Agent C. With every single handoff, context is lost, data is altered, or, a hallucination is introduced.
Well, because they're essentially just summarizing the summary.
Exactly, just like kids whispering in a circle. The message inevitably gets scrambled by the time it reaches the end.
But with a shared file system, how does that change?
With a shared file system, there is no whispering. There is no handoff of interpretations at all. Instead, there is one central, immutable source of truth.
Like a central database.
Think of it like a massive, highly secure Google Doc that every single agent has open at the exact same time. Agent A does its work and updates the file. Agent B doesn't ask Agent A what happened. Agent B goes directly to the shared file and reads the exact unaltered data.
Oh man, that is brilliant. You removed the communication layer entirely.
Yes.
They aren't talking to each other. They're all just looking at the exact same irrefutable reality.
It completely eliminates translation loss. And having that shared reality doesn't just prevent data degradation either.
What else does it do?
Well, once agents are looking at the exact same irrefutable file, you've accidentally solved the biggest hurdle to autonomous business.
Which is?
Trust. If they trust the state of the task, they can actually start transacting with each other.
Which introduces the wildest part of this entire stack, the economic layer.
Yeah, this is where it sounds like science fiction, because the environment is strictly defined by the blueprint, and the progress is continuously verified by the shared file system and the shadow agents. These AIs can now discover each other,
Sure.
they can hire each other for specific subtasks, and they can actually pay each other for completing those tasks.
Hold on, wait a second. If they are paying each other, they need a budget, right?
They do.
Are we talking about giving AIs autonomous control over enterprise wallets? Because as a business owner, that sounds absolutely terrifying. I mean, an AI could just drain your bank account, hiring 1,000 other AIs.
And that's the beauty of architectural determinism.
Yeah.
The AI doesn't have an open-ended credit card to just do whatever it wants.
Oh, thank God.
Right. The budget is dictated entirely by the original blueprint.
How does that work?
Let's say the blueprint requires translating a Japanese financial document. The blueprint allocates exactly $2 for that specific node. The managing agent sees the node, finds a specialized nano agent that does Japanese translation, and pays it a fraction of a cent to execute the task.
Wow.
It happens completely autonomously, but strictly within the financial walls built by the architect. A human never needs to intervene, approve a budget, or schedule a sync call.
The AI is literally outsourcing to other AIs within budget to get the job done faster.
Exactly.
But wait, why do we need a blockchain for this? Because the final piece of the Openserv stack is on-chain verifiability. Why not just use a normal centralized SQL database to track these payments and tasks?
Because you're dealing with autonomous, non-human entities moving real money and executing enterprise-level tasks. A centralized database that a single human admin or a rogue piece of code can't alter is a massive liability. Machine economies require absolute, undeniable trust. By putting this on-chain, you create an immutable, cryptographically secure ledger.
So nobody can cook the books.
Exactly. Every single decision, every handoff, every audit by a shadow agent, and every microtransaction in the economic layer is recorded immutably.
Which I'm sure the lawyers love.
Oh, enterprise compliance absolutely demands it. If something goes wrong or if human auditors need to review a pipeline, you don't have to guess what the AI was thinking.
Right.
You have a flawless mathematical record of exactly what happened at every single node and proof of work for every cent spent.
To bring this full circle for everyone listening right now,
Yeah,
you don't just have a skyscraper being built by a bunch of guys winging it based on vibes.
not anymore.
You have a master blueprint. You have shadow inspectors checking every single brick before it's laid. You have a shared ledger of all the materials so nobody loses the plot. And the workers are automatically paying each other based on flawless completion of the plans, with receipts that can literally never be altered.
That is the power of architectural determinism right there. It takes AI out of the realm of, like, unpredictable magic and turns it into reliable industrial engineering.
Let's summarize what we've uncovered today, because this really shifts how we need to think about the tools we use moving forward.
Definitely.
What we've learned from this leak and the analysis of multi-agent failures is that the era of the freestyle AI agent is ending.
It has to.
It has to end because the math simply doesn't support it. Compounding errors destroy unscripted pipelines, and throwing 30 times the budget at the problem just gives you a much more expensive coin flip.
The future undeniably belongs to pre-scripted, highly structured environments. Architectural determinism is how we move from AI as a novelty to AI as actual infrastructure.
Yeah.
We have to stop expecting auto-regressive models to logically think for themselves and instead build systems where they flawlessly execute a predetermined blueprint.
And for anyone listening who is wondering what's next or how they can actually get their hands on this architecture, the source notes mention that the Openserv or SRV reasoning system is currently in private beta.
Yep, it's currently private.
But it will soon be accessible via a public API.
And when it launches, it will feature 6 custom-trained models ranging all the way from nano to ultra.
Oh, that's great.
So depending on whether you need the master architect to draw the blueprint or just an incredibly cheap, efficient nano model to execute a tiny node, you have the exact right tool for the job.
The bottom line is, you no longer have to pay frontier rates for a coin flip. The tools to build deterministic pipelines are here, and they are already running the infrastructure of tomorrow.
It is a profound shift in how we deploy intelligence.
It really is. Which leaves us with one final, frankly provocative thought for you to mull over as you go about your day.
Let's hear it.
We started this deep dive by imagining the chaos of building a skyscraper with vibes instead of blueprints. But if we are truly entering an era of architectural determinism, an era where AI doesn't just execute tasks, but uses an on-chain economic layer to audit, hire, and pay other AIs to complete a blueprint flawlessly.
Yeah.
At what point does your job shift from managing the work to simply giving the machine its budget and getting out of the way?